Now in this lecture we are going to expand upon the previous lecture where we first looked at linear regression and we used the STEAM data set. Now we're going to actually use the R programming language to solve it. So let's see how that's done. So let's start off by reading in the data set. So this code has already been pre-written, and let's load in the data set. So this is the STEAM data. Let's read that in. And if we take a quick look, you can see that we have 25 records. And here we have the steam usage. I think that's pounds of steam pressure. This is the average temperature outside during the month, and this is in degrees Fahrenheit. And this is how many days the factory was open during the month. So now let's take a quick look at the data itself. It's always a good practice. So you can see here that the structure of the data is we have three numeric data variables: steam usage, average temperature, and operating days. Summary of the data, you can see we don't have any missing values. We have the mean, median, etc. This is just normal good technique to always look at your data. And the dimension of the data is 25 rows, 3 columns. So that's now in the command to do a linear regression is LM for a linear model. Now in the past, what we have done is I've created in previous models like decision trees and random forests, I would create a variable called target, and then I would just assign my target to this guy. And then I would say the linear regression model is equal to target, and that's what I would do. And that tends to work very nicely for some models, but this is an idiosyncrasy, a little bit an inconsistency with R, is that this doesn't work with the linear model command. So if I do this, you're going to get an error message. So let's, oops, why don't we copy it again? Copy, and if I run this, it says, look, this doesn't work, I can't use it. So because I'm not allowed to use that, we just have to hard code in the variable. So let's comment this out, and I'll show you how you're supposed to do it. So as opposed to using a variable here, I'm going to have to actually type in the word steam use. So let's do that. And let's make this. And there we go. So now, this command right here, I have now generated a linear model. And if I type in the linear regression model, there it is. It says, oh, the coefficient is this, average temperature there. So that tells me what the coefficients are. But a more useful command is summary. So if I do summary of the model, this will tell me all sorts of interesting information. So in this case, the intercept is 9.126. The average temperature is negative 0.07. So whatever the temperature is, you multiply that by minus 0.07. And operating days, you multiply it by 0.20. So that's, what that, so what that means. So these are the coefficients. Also, we can look over here and we can look at the R squared, and from the lecture we see that's 84.9, but we don't want to use that. What we're going to want to use is the adjusted R squared value, which is 83.54%. So that tells us how good or how accurate this model is. And just to show you how to use this model, we can plug this formula in to R, and again, you see it's 9.126, so we're going to say that the predicted value is going to equal 9.126 plus minus that guy right there times the average temperature, and this guy here times the operating days. So if I run this command, and I type P1, these are all the predicted values. Just for fun, let's take a look at this using Excel. So here I have an Excel spreadsheet that has been opened up. So let's just take a quick look here and say, we're going to say this is the intercept. This will be the average, oops, we'll do the average days, or yeah, our average temp. And over here will be the operating days. We'll just call it days. And so what we'll do here is we have the intercept is equal to it's equal to that. The average temperature is equal to, or the coefficient of that. And then over here we have the operating days right there. So what would happen is, let us assume that we have the average temperature. Let's just take a quick look at the data here. So we'll do, so the first guy here is 35.3 degrees and 20 days. So you can say 35.3 degrees Fahrenheit and 20 days of operation. So then you just simply say, let's just, this guy will here equal that. This guy will equal this times this, and this guy will equal U times U. And if we add them all up, we get a predicted value of 10.6 pounds of pressure. And the real value is 10.98. So we were pretty close. And let's just, if we look at our model, 10.6. So the neat thing about this is, what's so nice about a regression model is once I have this formula, I can say something like the guy who owns the factory can say, well, what if it's a really cold winter and it's 0 degrees out? Then then we would say that we're going to use 13 pounds of pressure. And if it's like, I don't know, minus 20 degrees, so it's really cold, we're going to use 14 pounds of pressure. So you can see here that, and that the factory owner says, well, what if we're closed half the time, 10 days, back down to 12. So you can see that this allows you to very easily use the model and to you can play what if analysis and do any sort of analysis, just it's a simple formula like this. And so we type this formula in by hand using R. And these were all of our predictions right here. But you can also do it the easy way, which is using the predict command. So I say predict, and this is our model, the linear regression model, and I'm going to give it this data frame. And this will give me predict 2. So if I type P2, there it is. So you can see these values are the same, 10.62, 10.62, 11, 11. So that's an easier way to do it using the R programming language. Now, if you recall, one of the things you will want to do is look at, really there's two things you're going to want to do. You're going to want to plot the well, let's first calculate the errors. So we're going to say the steam usage, 10.98, minus what we predicted, 10.62. So let's do that right there. And if we do R1, this is going to give us our errors. So two things we're going to want to do. The first thing we're going to want to do is we're going to want to graph what really the real answer versus what we predict. And if this model is any good, it should be sort of a straight line. So let's take a quick look and see if this is any good. And look at that. It's a nice straight line there. Well, it's not a really nice straight line, but you can see here that this model seems to be pretty good. You know, we predict, this is the real answer, and this is what we predict. And if we predicted it to be 8, it's pretty close to 8. We predict 11 ounces, it's pretty close to 11 ounces. It's a nice, reasonably straight line. This is telling us we can use this model for predictive purposes. You also want to look at the errors and see if there's any discernible pattern. And let's take a look. And if we look at the errors, so here's our steam use, and this is our error. And you can see here it looks pretty random. So this is a homoscedastic error distribution. In other words, it looks pretty random. There's no pattern there. So that tells us this is probably a pretty good model. So anyways, this is a very simple explanation of using linear regression using the R programming language.